Welcome to another episode of Coffee with Jeff. For this episode, I've been asked to talk about AS5488. Australian Standard 5488 is the standard for the classification of subsurface utility information. It was developed to address the need for a consistent and reliable method for classifying the location and accuracy of subsurface utilities. Prior to its establishment, the lack of standardised practices in identifying and documenting underground utilities often led to discrepancies in data quality, resulting in increased risk during construction and excavation projects, such as utility strikes, project delays, and added costs. The development of AS5488 back in 2013 was driven by the construction, civil engineering, and utility industries' need for a unified framework to improve safety, reduce risk, and enhance the accuracy of utility location data. This standard provides a systematic approach to classifying subsurface utilities based on the quality level of the information available, ranging from quality level A, which is the most reliable, involving physical verification through exposure, through to quality level D, which is the least reliable based on existing records without physical verification. By implementing AS5488, we can achieve greater certainty and consistency in utility mapping, leading to safer and more efficient project planning. The three main attributes of AS5488 are assigning the quality levels, standardisation in marking paint colours, and the documentation and reporting process. So let's have a look at the quality levels. Quality level A represents the highest standard of accuracy and reliability. To achieve quality level A involves physically verifying the location of utilities by exposing them through direct means such as vacuum excavation, hand digging, or other non-destructive techniques. This process allows the precise determination of utilities' horizontal and vertical position. Some of the benefits of quality level A include enhanced safety. It reduces the risk of accidents and utility strikes during construction and excavation activities. Cost efficiencies. It can prevent costly delays and repairs by providing precise utility location data up front. Next level is quality level B. This information is obtained using non-invasive geophysical methods such as electromagnetic locating. Quality level B provides a high level of accuracy for subsurface utility information through the use of non-invasive detection methods and utility maps. This level of data is essential for planning and preliminary design phases of projects where a balance between accuracy and cost efficiency is required. Whilst not as precise as quality level A, quality level B provides reliable data on the horizontal position of utilities within a tolerance of plus or minus 300 mm, whilst the vertical position, in other words the depth, is estimated with a tolerance of plus or minus 500 mm. But the utility's position is less certain compared to quality level A. Quality level B data is most often used for preliminary design. It's used for risk assessment. It helps identify areas where more detailed investigation, such as quality level A, may be needed. It's used for feasibility studies to assist in assessing the feasibility of a proposed project. By implementing quality level B, project stakeholders can achieve a significant reduction in the risk of utility-related issues during construction, leading to a safer and more efficient project execution. Quality level C is data that is obtained through existing records and limited surface geophysical methods, often combined with survey information. Quality level C involves gathering subsurface utility information by correlating existing utility records with observed surface features. such as pits, manholes, etc. This level of data is less accurate than quality level A and quality level B, but still provides valuable information for initial project planning and risk assessment. Applications of quality level C include feasibility studies, preliminary design and utility coordination, where information is needed at the early stage in the planning process to assess the potential impact of existing utilities. It can assist in the development of initial project designs by providing rough layout of underground utilities. Whilst quality level C does not provide the high accuracy of quality levels A or B, it's a valuable tool for gaining an initial understanding of the subsurface utility landscape. It can help projects teams to plan more efficiently and identify where further investigation is required. Finally, we have quality level D. This represents the lowest level of accuracy for subsurface utility information under the Australian Standard. This level is based primarily on existing utility records or documentation without any additional verification through physical or geophysical methods. Quality level D information is derived from utility records, historical maps, and documentation. This includes as-built drawings, GIS data, and utility plans that may be outdated or incomplete. There is no physical verification of the utility location or its condition. The information is purely based on the available records and does not involve any direct measurement or geophysical survey to confirm the actual presence or location of the utility. Therefore, it provides the least accurate data amongst the quality levels, with a high potential for errors and discrepancies due to the reliance on potentially outdated or incomplete records. Whilst quality level D provides the least precise information, it can still be a useful tool for gathering some initial understanding of subsurface environments when higher accuracy levels are not yet required. However, it is generally recommended to follow up with a more detailed investigation, such as quality level A or B, to ensure greater accuracy and reduce the risk of utility-related issues. The next part of the standard identifies a standardized marking color system. As part of the document, a paint system was implemented to be used when marking the presence of utilities on the ground. Without going through all the colors, the main colors making up the standard are blue, which represents potable water, orange for electricity, yellow for gas, white for comms, purple for recycled water, etc. Please, 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 wherever possible, use the paint colours nominated in the standard for the individual utility. This level of consistency will benefit safety across the industry and remove any possible confusion. There is an Australian standard for a reason. We should all be complying with it. The third part of the document is to do with the documentation and reporting requirements. The standard sets out a detailed guideline for documentation and reporting of subsurface utility information. This includes specifications for utility mapping, for the data collection methods, and the presentation of the utility information in a clear and consistent format. Proper documentation ensures that all relevant data is accurately recorded, easily accessible, and can be effectively used for future reference and project planning. Look at these two plan drawings. The one on the left is beautifully drawn. It shows both above and below ground features. Someone has paid a lot of money to have a surveyor on site to pick up all of the site's attributes and then have a draftsman compile the information. The sketch on the right has been hand drawn with the information about the site and the utilities found on that site. Because whoever has drawn these plans did not document the quality level of the information, it has to be assumed that both have been drawn at quality level D. In other words, the least accurate and posing the greatest risk of the four quality levels. However, looking at both of these drawings, it would be very easy to assume that the draftsman's drawing on the left is the most accurate. Unfortunately, this assumption would also pose the greatest risk. Finally, just a point of interest, the plans that we receive from BIDA, from their plan request service, are drawn at quality level D, the lowest quality and the highest risk of all the quality levels. Just have a look here on the Telstra plan. Well, that's it for today. I hope that you find these of some value. If there is any topic that you would like to see discussed, just drop me a line on my email. Stay safe.